Okay, so here I am in Tinkercad looking at the Sparkfun Inventors Kit projects 1C, and I've kind of worked towards 1D as well. But let's just focus on 1C for a moment. So you can kind of ignore this side here. We'll get to that on the next video. We have this left over, the potentiometer from, we have that left over from the previous video. And we have a photoresistor. Let me just clean this up for a moment. So the photoresistor is here. It says photoresistor, and the other resistor is here, and I'm not sure if that's 10K, so let's just see if that's correct. I can't read that. 330 ohm and a 10K, so that looks like the right resistor. This would be the 330 ohm current limiting resistor for the LED, and this would be the 10K resistor for the voltage divider. You'll notice that we've got another bit of information about this idea of a voltage divider. Last time in the previous project it was just kind of this part, and we were talking about how the potentiometer is a voltage divider, that the V out point, if this is kind of one continuous resistor, this wiper kind of connects to it, and depending where you physically move it, you change the size of this resistor versus the size of that resistor. If this was in total 10K and you move this right up to the top, then the R1 value would be basically no resistance, and this bottom one would be 10K resistance. If in fact you had put the potentiometer somewhere in the middle, you would basically have 5K on this side and 5K on this side. And the reason I think this is important is because when you come over here, this is a new thing. This is the photoresistor, and what they talk about in here is that the fact that the Arduino has a way to measure incoming voltages on its analog input. It doesn't have a way of measuring it does not have a way of measuring resistance. Like a meter, you can measure the resistance of this. It's the resistance of this that changes with the amount of light. So a photoresistor is a resistor whose resistance is proportional to the amount of light it receives. And if you wanted to do something useful, like the last project is the RGB nightlight. So imagine you're designing some kind of new nightlight. Obviously, you don't want a feature of that nightlight might be that you want it to light up only when it's dark. So this would be the way that you can determine if it's dark. You would be able to check its resistance and then find out if that corresponds to the room being dark. Except you can't measure resistance with the Arduino, so how do you do it? Well, if you configure it in this setup, we're back here. The only thing is that, and we know what happens with the voltage out here, this varies, and they're giving you the exact kind of calculation that you can use to determine how it varies. But this varies depending on, the ratio or the values of these resistors. This resistor value varies. This resistor value does not. This is the fixed 10K resistor. Let's just go back to our circuit for a moment. So this is the fixed 10K resistor hooked up to plus 5 volts. Current goes through the resistor, okay? And, a tiny bit would go through here, but we'll come back to that in a moment. And then this is connected to the photoresistor. There's resistor 2, and this one can change depending on the light, and that goes through, oh, I'm sorry, I had it backwards. This is the plus 5 volts here, the red one, goes through this resistor, and then goes through this resistor, and it's connected to ground. So they've kind of switched it around between the two, but it's still the same idea, and it does still the same thing. This number will be different, but anyways, that's kind of what we're looking at in terms of how it's set up. So what's straightforward is that really we're just going to read this V out on an analog in, just like we did with the previous activity. Okay, so let's look at our Tinkercad. Let's do the same thing just for a moment. Let's drop the meter on here and see what we come up with. It's always good, like I said, it's always good to try to figure out right, so I really need to drop it into a point. And so this is positive, so we'll take the positive and we'll put it into the middle point here. Okay, so that's what our analog was, analog in. And we'll hook this up to the input, the ground. Okay, so I think I made the connection there. Find out in a moment. And you'll notice something. Oh, right, so there's some code left over from this morning, which is not working. And so, okay, so simulator is running. And this thing, when we click it now, we can see we have an adjuster. This is like fully dark setting. And what we can see is that somehow fully dark seems to not measure really any voltage at all. So we could look at those formulas and we could try to think about what that means. We want to be careful that we get the order of the two resistors correct in that voltage divider circuit. But you can see that this is now getting nearly 5 volts now. So it's almost like the wiper, that if this was the other part of the resistor on the potentiometer, it's almost like this wire is all the way over and almost touching the 5 volts at this point. This amount of resistance must be really quite low right now because we're almost getting 5 volts. That seems quite low, and this must be quite high because by the time we read this point on the meter, we're getting almost no voltage, which means that this must be a big amount of resistance, and almost all the resistance has been kind of, all the voltage has been kind of used up. Let's just disconnect it and do one other thing. I know that this is really not what the activity is asking you to do, but I think this will help with the understanding of what's going on. So I've disconnected the resistor, okay? So this side is connected to the meter, and this side is connected to the meter, and this is not connected to 5 volts or the Arduino anymore. So it's just connected to the, and you know what, I'll just move the resistor too while we're at it. So this thing is just fully disconnected. So let's read it in terms of resistance. So we'll flip the meter to resistance, and we'll run it again. Where's our setting? So our setting here was almost no resistance. And you can see that is, well, that's not a lot of resistance. We're still below 1 kilo ohm. So, and you can see as it gets brighter, we're just, edging further and further down. What's the least amount of resistance we can give it? I don't know, half a kilo ohm, 500 ohms. This was still almost 5 volts coming through. Now, so relative to this, and there's where the calculation of the voltage divider happens, relative to this, right, this 1K value versus this 10K value, that's still pretty much, that's still pretty small. It's 1/10, and that's pretty small. So as we get closer to here, you'll see this is going up and up and up. And now we're actually really quite high. We've got 10K here, and we've got nearly 200K here. So we're nearly 20 times greater than this resistor at this point. So that's a great amount of variability in its resistance. And that should kind of indicate that we should get almost no voltage here, which is what we already saw, and almost 5 volts there. So we already know what's going to happen when we plug this into analog in. So that meter, I think we're done with that. So let's put it back to where we were, which was that we got 5 volts coming into resistor 1, the photoresistor into resistor 2, back down to ground, and then this thing was our input on these 2 points. It might seem kind of weird, but it's like the junction point between these 2 resistors. So, and that's A0. Let's just print it out. Serial print it. So LDR is our A0, and we'll print it. And we'll watch what happens on the serial monitor. And we better move this whole thing over so we can play with the light setting. So right now we are on the high resistance, low voltage setting, and we're getting 54 out of, the analog read varies 10 bits, so it can go from 0 to 1023. So almost nothing on analog read, and it should edge gradually up to 1023 as we get up here. Now maybe we can't quite get to 1023 because there is some resistance here, right? So we can't fully get to 1023 like we can't fully get down to 0. There's just a bit of a resistance here that we can never make it fully go away. Like on the potentiometer, when we turned it this way, this was almost 0, right? But this is, fixed, so it's never going to go away. So we have a boundary there that we kind of on either side. But this is a voltage divider in action. They both are, but this one's really showing us how we can make use of the fact that some device like a photoresistor, which varies in voltage under certain conditions, and there's other things that will be like that, things that any sensor will probably work something like this on some way. So some physical property that causes this thing to vary its resistance based on light, but it might be because of heat, or it might be because of tension or pressure or flex in metal. It might be all sorts of different things. And how do we work with that? Well, we use this voltage divider setup and we read it off into our code. And then from there, it's whatever we want it to do. Oh, it's too dark, turn on the light. Other things can happen. So let's stop there. Hopefully that gives you some more information. And when you read about voltage divider, you can look at that formula, hopefully make a little more sense of it.